Section 5.2 has to deal with perpendicular and angle bisectors. So let's take a look. Theorem 5.2, the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So let's draw a picture. We've got a segment AB, and I've got the perpendicular bisector that passes through M. So in other words, if PM, put a point P on the bisector. If a point is on the perpendicular bisector, so if PM is perpendicular to AB, and if MA equals MB, in other words, what we're saying here is that PM is perpendicular to and goes through the midpoint, then PA equals PB. Then the point is equidistant from the endpoints. And we can pick a point anywhere on the bisector. It doesn't have to be where I picked it. So if I pick a point here, that is also equidistant from the endpoints. As long as the point I pick is on the perpendicular bisector, that should be MA and MB, my bad, bisector, MB, MA are equal, then the point, whatever point I pick, is equidistant from the endpoints. Then we have a converse of that. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. In other words, if a point P is equidistant from the endpoints of a segment, so if PA equals PB, if these two things are equidistant, then P is on the perpendicular bisector. Okay, so if I draw a line from P perpendicular, then that is on the bisector. So the converse and the original. So what are we going to do with this? So let's say that I give you a triangle or a drawing, and I tell you that B is perpendicular to AC and that AM is equal to CM. And then I tell you that BC equals 4x and BA is 6x minus 10. Since B is on the perpendicular bisector of AC, I know that BC is equal to BA. And it's a pretty easy task to solve this equation. Add 10 to both sides, bring the 4x over here. I get 10 equals 2x, or x equals 5. Okay? And I like to put my x's on the side that makes them positive. I could have also solved this just as easily by subtracting the 6x and getting negative 2x equals negative 10. This is not writing very well right now. And then dividing by negative 2, I get x equals negative 5. Same answer. Oops, positive 5. Okay? All right. Theorem 5.5. Whoops. Theorem 5.4. That's better. If a point is on the bisector of an angle, then the point is equidistant from the sides. Now the first thing we have to talk about is how do I measure the distance from a point to a line? To measure the distance from a point to the line, I always take the shortest distance, which is the perpendicular. So if I want to measure the distance from point P to this particular line, I always go to the shortest distance. I don't measure the distance out this way or out this way. I always measure to the perpendicular. So that's the first thing we want to look at. So a point is on the bisector of an angle. So let's draw an angle. Let's call it Q, P, and R. Okay, so angle QPR. And then I have a bisector. I'm going to say that QS, and it's a ray because it starts at Q and goes this way. QS, put a point there, is, ooh, yeah, I need a special point. Put it closer to that. QS is bisects angle PQR. SP is perpendicular to QP, and SR is perpendicular to QR. So I've drawn a perpendicular bisector, and then I've drawn some perpendicular lines. I'm sorry, I've drawn a bisector, then I've drawn some perpendicular lines to measure the distance from S to the two sides. If all of this is true, if this bisects the angle, and if this point is drawn so I can measure a perpendicular distance, I can then say that SP equals SR. Okay? The converse, if there's some point in the interior of an angle that is equidistant from the sides of the angle, then the point is on the bisector. So if I call this S, and this is my angle again, so if I draw a perpendicular distance to measure the distance, and if I say that SP is perpendicular to QP, I know that I'm measuring the shortest distance then, and SR is perpendicular to QR, so I know that I'm measuring the shortest distance, and if SP equals SR, then QS bisects angle PQR. Okay, so the converse. So let's look again at what this might mean for us. So if we have a diagram, and I know that draw some perpendiculars. So if I know that QM is perpendicular to MS, and I know that QP is perpendicular to SP, and if I know that these two angles, that angle MSQ is equal, and I'll put the measure, we could also say they're congruent, measure to PSQ. In other words, I'm saying that QS, it's driving me crazy, bisects angle MSP, then I know that QM equals QP. So if I again say that maybe QP equals, that's just an arrow, equals 2x plus 5, and if I know that this side equals 7x, I can solve for x by saying 7x equals 2x plus 5, and 5x equals 5, so x equals 1. Right, so that's it. We'll do a little bit more of this in class, but write down the theorems, get a good idea of what they mean, and that's it.